I'd now like to discuss a possible solution that involves something called derivatives, where if you've taken a calculus class before I asked you this initial question, and it's been ingrained in your head as much as it's been ingrained in mine, my immediate thought when I'm attempting to find maxes and mins of a function is to think about derivatives. Now, if you have seen calculus before, or if you haven't, the definition of a derivative of a function at a particular point is given by this strange limit that you see right here. Now, another thing that might be totally ingrained in your head from a calculus class is that this, the definition of the derivative of the function f of x at the point c, is supposed to be entirely synonymous with the slope of the function f of x at the point c. I distinctly remember learning calculus for the first time and having absolutely no idea why on earth this limit meant anything about the slope of the function f at the point c, and it's really not a huge stretch, but it was a big point of confusion for me. So I wanted to take a minute to talk about that association and why this definition of a derivative of a function at a point talks about its slope. And the real answer from that comes from a really good picture and an algebraic rewriting of this limit. So what I'd like to do is, instead of thinking about this formula for the equation of the derivative of a function, I'd like to change it a little bit. Before, our denominator was just the letter h, and now our denominator is just the letter h, because adding in this c and subtracting it away is like adding 0 to an h in the bottom. But when I rewrite the limit in this way and take a look at what that means in terms of my picture, I start to see something that I recognize. So if this is my input point c, there's a point on my function, f of c, where the x value is c and the y value is f of c. If I think about c plus h as some point over here on the number line, I've drawn to the right of c, but h could be a negative number, so I could have c plus h strangely being over this way as well if I really wanted to. But here's a point, c plus h. I can view that as an x value that's going to be input to my function, and when I do that, the output, or y value, would be f of c plus h. I could then draw the line between c, comma, f of c, and c plus h, comma, f of c plus h, and to compute the slope of that line, I would compute the change in y values divided by the change in x values. And in fact, that's precisely the thing that we see right here. The change in y values divided by the change in x values. That I see as giving the slope of a line. And what line? The line connecting c, f of c, to c plus h, f of c plus h. The limit part just means that we want this value that we add on to the c to get smaller and smaller and smaller. So we move this point c plus h closer and closer and closer to the point c until it's so close that the line connecting these two separate points will end up being this tangent line to the curve, and the slope of that tangent line would be given by this expression. So the main takeaway from this slide as we move forward is that when we talk about a function having a derivative at the point c, which we denote with this little f prime notation, this thing means the derivative of the function f at the point c. That value is giving us the precise slope of the function f at that point.